Okay, let's unpack this. When you're standing in a large factory, refinery, or any, sprawling industrial campus, fire safety isn't just a handful of extinguishers.
No, not at all.
It's a critical, multi-tiered defense system. It's
Yeah.
built on just massive infrastructure.
Exactly. And we've been looking at a stack of sources that make this really crucial point.
Which is?
Not all industrial firefighting equipment is created equal. I mean, these systems are designed for fundamentally different scenarios and, this is the most important part, completely different users.
And that's our mission for this deep dive. We are getting into the real nuts and bolts of industrial fire protection by contrasting two major players.
The big ones.
On one side, you have the fire hydrant system. That's the heavy-duty, high-capacity backbone.
Right.
And on the other side, you have its nimble, accessible sibling, the first aid fire hose reel system.
And we need to look at all of it, the components, the specs.
And ultimately, why one requires a highly trained, dedicated team and the other, well, the other has to be immediately usable by any occupant. Whoever happens to be there when an emergency starts.
That core distinction is everything. High flow capacity versus single-person accessibility. That's the key to understanding how these large facilities manage their risk.
One is for a full-blown catastrophe.
Established blaze. The other is the first line of defense, designed to stop a small incident from ever becoming that catastrophe.
So let's start with the big gun then, the primary responder, the fire hydrant system.
Okay.
We're talking about the infrastructure built to deliver just massive volumes of water with intense pressure to an already established fire.
And when you look at the infrastructure required for that, what's fascinating is the sheer scale of the commitment.
It's not trivial.
No. It all begins with the dedicated water supply, the static suction tank.
And this isn't just hooked up to the city water line.
Not at all. This is a private, dedicated fire reserve. Our sources indicate that, depending on the hazard level of the facility, this tank has to hold a significant independent capacity. We're often talking upwards of 200,000 liters.
Wait a second, 200,000 liters?
200,000, yes.
That's not just a big tank. That's like a small lake dedicated solely to firefighting. Why so big?
It's all about sustainability. An established industrial fire burns incredibly hot, it burns large, and it often involves complex materials.
Right.
So that 200,000-liter capacity, it's there to ensure that a trained team can pump high volumes of water for an extended period, potentially hours.
Without relying on outside help.
Exactly, without relying on municipal supplies that might fail or just be overwhelmed during a wide-scale disaster. It's an act of total self-sufficiency.
Okay, so that's the water. Now, the brain and the muscle of that capacity are in what's known as the pump house.
A heart of the system.
I like to call it the triumvirate of redundancy, because you don't just have one pump, you have three, and each one plays a really specific, critical role.
All to ensure the system will work when it's needed.
So the first is the standard, hard-working component, the main electric pump.
Your primary workhorse. It handles the water delivery when power is available.
But we know industrial fires can often coincide with power disruption.
Of course. Electrical failure, grid failure. It happens.
And that's why the second pump is the standby diesel pump.
This redundancy is just non-negotiable for critical safety infrastructure. It has to be there. It guarantees that high flow capability, regardless of what the electrical grid is doing.
And then there's the third one, the unsung hero of the whole setup.
The jockey pump.
Exactly, the jockey pump. If the main pump is the powerful giant, the jockey pump is the peacekeeper.
That's a perfect description. Its role is simple, but it is absolutely critical. It continuously monitors and maintains the pressure across the entire piping network.
To a specific target level.
Right. So if there's a minor pressure fluctuation, like from a small leak or even a temperature change,
The jockey pump kicks on.
it kicks on to compensate. And this prevents those massive, power-hungry main pumps from engaging every single time there's a tiny pressure drop. It keeps the whole system taut and ready without false alarms.
Okay, so if the pumps are the heart, the pipes are the arteries. Once that massive volume of water is pressurized, you need tools above ground to actually use it.
To manage that immense force, yeah.
So now we're dealing with the pillar hydrant, the above-ground stand post, typically with one or two outlets, and the red metallic or FRP hose cabinet next to it.
The big red box that holds all the serious gear.
And when you examine that gear, you understand immediately why training is so critical.
Absolutely. Everything about this system is designed for volume and force, not for ease of use by a layperson.
Let's get into the specifics. The hydrant valve itself. It's typically 63 millimeters,
That's about 2.5 inches.
roughly the diameter of your wrist.
Hmm.
And it's usually an oblique type, made of, durable gunmetal or stainless steel.
And that oblique design actually matters. It lets the valve handle immense pressure and be opened or closed efficiently, even when water is flowing at high speed.
The hose itself reflects that need for volume, too.
It has to. It's also 63 millimeters in diameter, 15 or 30 meters long, and it's reinforced rubber-lined, or RRL.
That internal reinforcement is everything.
It's what stops the hose from bursting when it's handling those incredible working pressures.
And the force management continues all the way through the connections. The couplings are these heavy-duty 63 millimeter instantaneous or threaded types.
Designed for a swift, secure connection under a lot of stress.
But here's where the physics gets really interesting. The branch pipe, or the nozzle, it has a huge 63 millimeter inlet, but the outlet is tiny, tightly focused, maybe 20 millimeters or even 16 millimeter.
And that constriction is the key to velocity. The system takes a massive volume of water and converts it into a high-velocity jet.
A jet that can penetrate a large industrial fire from a safe distance.
Which is why you need specialized training. It's why you need an operating wrench just to manage the valves and couplings. You can't do this by hand.
Okay, so that's the heavy infrastructure. It's built for trained teams.
Right.
But wait, if the hydrant system is the gold standard for putting out big fires, why doesn't every facility just install dozens of those? Why bother with the smaller system?
Because response time is everything.
Right.
A small fire that starts in a waste bin or near a machine, it can be extinguished in seconds if someone acts immediately. It takes minutes to get a high-pressure hydrant system going.
And that's the crucial gap.
That's the gap filled by our second system, the first aid fire hose reel system.
Absolutely. So let's pivot now to the other end of the scale. This is all about immediacy, accessibility, stopping the problem in that incipient stage.
That crucial first few minutes before it really spreads.
This system has to be easily and safely usable by anyone on site.
From the janitorial staff to the CEO. Not just the dedicated fire response team. It's all about saving time.
And the setup reflects that. It's a sharp contrast to the, dedicated static suction tank and pump house we just talked about.
Completely different world.
Here, you have a wall-mounted hose reel drum, which can often swing 180 degrees for maximum reach.
And it's connected not to a special tank, but usually to the building's existing water supply, potable or utility water, through a simple ball valve.
The piping is different, too. It's not the high-diameter stuff feeding the hydrant.
Not even close. We're usually seeing smaller pipes, 25 millimeter to maybe 50 millimeter galvanized iron or mild steel pipes.
Which makes it cheaper and easier to integrate into a standard building.
For sure. But the contrast in the hose size, that's probably the most dramatic illustration of the difference in purpose.
So we went from a 63 millimeter RRL hose.
Right, the big one. To a hose reel system that uses a standard 30-meter length, but the diameter is only 19 millimeter.
3/4 of an inch.
Or maybe 25 millimeters, so 1 inch. You can think of it as a very, very heavy-duty, kink-resistant garden hose.
And that kink resistance is a critical safety feature here.
Oh, absolutely. It's made of heavy-duty braided rubber, or PVC, and it's engineered to allow rapid, unimpeded deployment by someone who might be stressed or confused.
Someone with minimal training.
Exactly. You don't want the water flow stopping 2 seconds after you pull it out because the hose kinked.
The nozzle simplifies things even further.
Much simpler. It's a user-friendly shut-off nozzle, twist or lever operated, usually brass or nylon. It's designed for intuitive use, not heavy-duty force management.
And the performance metrics, they really confirm its purpose as immediate first aid.
The flow is lower, it's controlled, and it's designed to be managed by just one person.
What are we talking about flow-wise?
A minimum flow rate of around 24 to 30 liters per minute. Now that's lower, but it's more than enough to cool and extinguish a small, localized fire.
And it has some reach.
It does. It can achieve a minimum jet range of about 6 meters.
And the pressure confirms the manageability. It's designed to operate at about 12 bar, and it's tested up to 18.
And that manageable pressure is the whole reason the system can be operated by a single person.
Which brings us to the crucial operational difference.
This is where all those technical specifications dictate the human safety protocol. The difference in hose size and pressure dictates everything about who uses it and how they're trained.
So let's focus on that critical distinction.
Yeah.
The manpower requirement. Because of that massive flow and the high recoil pressure, the kickback, when all that water is forced through the tight nozzle on the hydrant system,
Right.
that system absolutely requires a minimum of 2 people to operate safely.
You're literally fighting the laws of physics, that recoil force, that backward push. It's just too much for one person to control while also trying to aim a precise jet of water.
So one person's at the valve.
One person has to be at the valve, controlling the flow and pressure, and the second person has to manage the shear reaction forces at the nozzle end.
And the training must reflect this physics. When you're dealing with a 63 millimeter hydrant hose, the training has to focus on very specific, almost athletic techniques.
It does. We're talking about a mandated two-hand grip.
And that critical wide leg stance.
Just to stabilize the operator and make sure they're not knocked off their feet by the water pressure, it is a specialist job.
Now contrast that immediately with the hose reel.
Day and night. Since the flow is controlled and the pressure is so much lower, it can be easily operated by a single person.
And the training focus changes completely.
Drastically. It's all about rapid deployment. The basic unwind open aim sequence. It is designed for decisiveness by any employee to make sure you lose minimal critical response time.
So if we zoom out here, what does this all mean for you, the listener? The technical specs we've been talking about, the 63 millimeter oblique valve, that 200,000 liter tank, the jockey pump, these aren't just arbitrary numbers on a blueprint.
No, they're fundamental safety decisions. They're based on the facility's overall risk assessment, and they separate the task into 2 distinct tiers.
Immediate low force suppression by any occupant using the reel.
And sustained high-flow expert suppression by a specialized team using the hydrant.
It just highlights beautifully that industrial fire safety isn't a single tool solution.
Never. It is always a tiered approach built on overlapping capabilities.
I think we've successfully unpacked that contrast between the high flow capacity of the hydrant and the immediate accessibility of the hose reel.
And before we wrap up, I just want to return to those systems we mentioned. The ones designed not for fighting the fire itself, but for just ensuring capability.
The silent sentinels.
Exactly.
We spent some time detailing that pump house trio, focusing on redundancy.
Right. And I want you to think about the philosophical weight of that standby diesel pump.
Okay.
It just sits there. It costs money, it consumes space, and its only purpose is to operate if and only if the primary system, the electrical grid, fails.
It's a guarantee against a double failure.
It is. And then there's the jockey pump, which constantly maintains that tension in the system. It saves the main pumps from unnecessary wear and tear caused by minor defects.
So these are systems built entirely on redundancy. They're designed to negate worst-case scenarios and tiny little defects before they can impact that critical moment.
They are.
So for you, the listener, here's a thought to take away. What other high-stakes areas of your professional or your personal life rely on this kind of silent, triple redundant backup? What systems are you maintaining, physically or maybe even mentally, that aren't used every day, but whose only job is to ensure that when the moment of crisis arrives, your capability is always there, ready to function?
Yeah.
Even if the primary plan has already failed.
Something to think about.
Think about that capacity planning until our next deep dive.